Have you ever wondered why heat waves ripple above a sun-drenched road during a sweltering summer day? It's a sight we've all seen, yet few of us could explain why it happens. That shimmer, that dance of light and heat, is more than just a mirage. It's a testament to the power of our sun and the energy it beams to our planet every second of every day. You see, heat waves are not just a summer inconvenience. They're a glimpse into the fundamental laws of physics at work, a visual representation of thermal energy and motion. So the next time you see that familiar ripple on a hot day, remember, you're witnessing a scientific marvel. Heat waves are not just an illusion, but a fascinating natural phenomenon that can be explained by science. To understand heat waves, we need to delve into the fundamentals of light, air, and temperature. Let's start with a simple question. What is heat? Well, heat is a form of energy that is transferred from a warmer object to a cooler one. It's the energy that makes your coffee hot and your ice cream cold. In the context of our atmosphere, the sun's rays are the primary source of heat. Now let's discuss what happens when this heat energy interacts with air. Air is a mixture of different gases, and these gases respond to heat in a very specific way. They expand. As the air heats up, the molecules within it move faster and spread out. This causes the air to become less dense or lighter than the cooler air surrounding it. The hot air rises and the cooler air sinks, creating a cycle known as convection. But where do heat waves come into the picture? Well, this is where the science gets really interesting. The difference in temperature between the hot air and the surrounding cooler air creates a gradient, and this gradient has a profound effect on how we perceive light. Light travels at different speeds through hot and cold air. In hot, less dense air, light travels faster, while in cooler, denser air, it travels slower. When light moves from one medium to another, in this case from hot air to cold air, it changes direction, a phenomenon known as refraction. So, when we're looking at a distant object on a hot day, the light rays coming from that object are refracted, or bent, as they pass through the layers of hot and cold air. This bending of light creates an optical illusion, making the object appear to shimmer or ripple. This is the mirage effect, and it's exactly what we see when we observe heat waves rising from a hot surface. So, in essence, what we perceive as a heat wave is actually a mirage caused by the refraction of light. So, we've unraveled the mystery behind those shimmering waves on a hot summer day. Let's take a moment to revisit what we've learned and highlight the key takeaways. Heat waves, those mesmerizing mirages we see on a hot day, are more than just an optical illusion. They are a visual representation of the science of thermodynamics at play. Due to the temperature difference between the hot ground and the cooler air above, light rays passing through these different air densities get refracted or bent. This refraction causes the light to deviate from its straight path, creating the illusion of waves or a mirage. This fascinating phenomenon isn't just a spectacle for our eyes, but it also carries significant scientific weight. Understanding the science behind heat waves helps us comprehend the broader principles of light, air, and temperature, and their interplay in our everyday lives. It illustrates the fundamental concept of refraction and gives us a tangible example of how light behaves differently in varying conditions. Moreover, this knowledge of heat waves is not just limited to the realm of theoretical science, it has practical implications too. For instance, it helps meteorologists predict weather patterns and climatic changes. It aids engineers in designing buildings and roads that can withstand extreme heat. It even assists biologists in understanding how certain animals use heat waves for survival. So the next time you spot those mesmerizing waves on a sweltering day, remember, it's not just a trick of the eye. It's an exhibition of the complex and beautiful science that surrounds us. It's a testament to the fascinating world of thermodynamics, where light, air, and temperature dance together in a breathtaking ballet. And there you have it, the science behind the phenomenon of heat waves, demystified and distilled. It's another reminder of how science is not just about complex equations and lab experiments. It's also about understanding the world around us, making sense of the natural phenomena we often take for granted. Next time you see those heat waves, you'll know it's not just a trick of the eye, but a fascinating interplay of light, air, and temperature. Until then, stay curious and keep exploring the science around you.